It is my distinguished privilege and profound honor to introduce our second keynote speaker for this day, Dr. Ashish Kumar Singhal, an eminent academician, distinguished expert in his field. Dr. Ashish Kumar Singhal is an accomplished academician and researcher with extensive experience in academia, industry, and consulting. He has made significant contribution to teaching, mentoring, and research. He has received a World Bank USA scholarship for his master's and an MHRD scholarship for his PhD. His sponsored projects have been highly appreciated by AICTE and RGPV Bhopal. Professor Singhal has published 53 research papers and 8 Indian patents and actively served as session chair, track chair, reviewer, and technical committee member in various conferences. He has received multiple Best Faculty and Best Paper awards. He has held key positions including Vice Chair, SAC IEEE MP Section, Secretary IES Society, IIC President, and Group Head of Electrical Engineering at Sagar Institute of Science and Technology. With my profound pleasure, I would now allow.
Thank you so much.
Thank you so much, sir.
वेरी वार्म गुड मॉर्निंग टू एवरीवन। 1 घंटा हो गया आपको बैठे बैठे, मैं ज़्यादा समय नहीं लूँगा, लेकिन कुछ तो तैयारी करके आया हूँ, बोलूँगा तो मैं भी, ऐसा तो नहीं कि मैं भी नहीं बोलूँगा। मैडम ने तो पूरी प्रिपरेशन करके आई थी, अब चांस अपना है। चलिए ठीक है, सो लेट्स स्टार्ट। इंटेलिजेंट ट्रांसपोर्टेशन सिस्टम and electrical vehicle driving and future of the smart mobility. As per the theme of your conference, basically your conference is dedicated to the system development. So I thought, what topic should I choose so that it can be relevant to your conference? Sustainable development is a very vast word. Everything which is related to the environment, it is called the sustainable. Or we have to keep the environment safe as much as possible through the sustainable things. So I took this particular topic because this is a very recent topic when the recent advancement is going on in the electrical vehicles. Now the intelligent transport system has been developed for the various solving problems across the world. And this also related to this SDG 9 goal. This is my content. We will discuss about the global EV market, what is happening across the world. We will discuss about the EV technologies. We will discuss about the challenges in the EV. We will discuss about the smart grid, how the EV plays or impact on the smart grids. We'll discuss about V2G and V2X. We'll discuss about the EV market challenges. We'll discuss about the policy and support, environmental impacts, and future trends as well. How many of you knows about the EV? कितने लोगों के पास EV है? सर के पास तो है, सबों के पास EV है, एवरीवन इज हैविंग। और अभी तो नहीं होगा सबों के पास, कुछ लोगों के पास EV, लेकिन कितने लोग लेना चाहते हैं? बस 2 लोग लेना चाहते हैं सर। आज आप भी लेना चाहते हैं? आप सब लोग क्यों EV नहीं लेना चाहते? दिस इज माई क्वेश्चन। वाई यू डोंट वॉन्ट टू बाय द EV? एनीवन? यस सर। यस, हाँ बोलिए।
ईवी आगे चलकर हमारे लिए इलेक्ट्रॉनिक गार्बेज बहुत ज़्यादा पैदा करेगा, क्योंकि लिथियम बैटरीज और इसकी कम लाइफ, जहाँ तक मुझे लगता है कि बैटरी पर चलने वाली चीज़ें बहुत ज़्यादा लंबे टाइम तक सस्टेन नहीं करेंगी। जैसे हमारी पुरानी टेक्नोलॉजी थी, आज मेरे पास एक बाइक है जो 25 साल से भी रन कर रही।
मतलब आपको ऐसा लग रहा है कि अभी ईवी कुछ दिनों बाद ऑब्सोलीट हो जाएगी मार्केट से? हाँ, क्रिएट कर रहा है इसलिए। अच्छा, आपको लग रहा है कि ये गार्बेज क्रिएट कर रहा है, दैट्स वाई इसके संग थोड़ी सी प्रॉब्लम है। सॉरी, हाँ। मैं आपको बताना चाहूँगा सर, आई वुड लाइक टू मेंशन वन थिंग. Electrical EV market size will be up to the 2023. It's in front of you. The company who will be involving in this particular market, definitely they will get benefited as much as possible. Why I'm saying, I understand, and the environment understand the issue of the EVs, because the battery, one battery made up, and as per the research, the 14,000 coal generation pollution will be similar to 100 mAh battery. Once you drive the one particular vehicle for the 14,000 miles, then you can compensate the environment pollutions. सिंपल भाषा में समझाता हूँ मैं आपको. 14,000 टन कोल जलने के बाद जितना प्रदूषण होता है उतना एक बैटरी बनने में लगता है. और उस बैटरी का डिस्पोज तो सेकंड है, आपका बिल्कुल, आप जो कंसर्न है बिल्कुल सही है, लेकिन उसका चैलेंजेस जो है हमारे पास, वो चैलेंजेस तो थे, लेकिन अब हम उससे बहुत आगे आ चुके हैं. आई विल डिस्कस इन माई पर्टिकुलर कीनोट. व्हाई आई एम सेइंग कि द ईवी इज हैविंग ए डिफरेंट इंफ्रास्ट्रक्चर्स. बिफोर द 10 years ago or back, we were in that particular situation when we can say that we are unable to dispose of battery. But now we are having several solutions. Why electrical vehicles? Everyone knows कि पेट्रोल तो है ही नहीं सर. High efficiency, fewer moving parts, because it has a fewer moving parts, that's why the efficiency is higher. Reduce the greenhouse gases. One country is called the Norway. आप लोगों ने सुना है ना नॉर्वे कंट्री के बारे में? आपको पता है वहाँ पे कितनी इलेक्ट्रिकल व्हीकल्स हैं? एवरीवन बाय द इलेक्ट्रिकल व्हीकल्स. द प्योरली बेस्ड रिन्यूएबल एनर्जी बेस्ड कंट्री. सबसे बड़ा, छोटा सा देश है लेकिन सबसे ज़्यादा उसने रिन्यूएबल एनर्जी पे काम किया है. एवरीवन इज यूजिंग द ईवी. लोअर नॉइस पॉल्यूशंस, टैक्स एंड फाइनेंशियल इंसेंटिव्स. और ये सब क्यों हो रहा है? बिकॉज वी डज नॉट हैव अ मच मोर फ्यूल्स. Now we have to go. This is our compulsion. This is the environment compulsions right here. So there are so many types of electrical vehicles. As we know that EV, that's a battery electrical vehicles, hybrid electrical vehicles, plug-in hybrid electrical vehicles, and fuel cell electrical vehicles. This is the latest one, which I'm talking about. You can say the hybrid electrical vehicles and plug-in hybrid electrical vehicles. What is the difference? यहाँ पर देख के आप समझ सकते हैं क्या? What do you know by the plug-in or hybrid electrical vehicle? Hybrid means which is not non-plug-in. And what do you know the plug-in or non-plug-in? Yes, sir. You want to say something? Yes. Yes. See. You can see the figure. There is a simple constructions. The hybrid what I'm talking about, and the plug-in means when there is a charging facility is there, right? इसके वो है क्या पॉइंटर? लेजर है इसमें? है? कहाँ से हिलता है? Okay, now you can see here we have the charging facility, that is why this is called the plug-in hybrid vehicle. And other one is battery electrical vehicle. Now this is a powertrain. This is a model of the EV where we can see that how our power is transferred from the motor. And this is a simple constructions. The traction motor is there, power distribution unit, traction inverter, BMS. BMS is battery management service or system. Onboard chargers, traction battery pack, and DC to DC converter as the battery. This is a simple configuration to the EV. This is the main cause why everyone has to monitor a battery. Battery pack basically consists of cells, parallel series, modules, series packs, are connected together. Battery pack consists of many tiny cells connected in series and parallels. And these tiny cells are basically dumb and highly unstable. आपने देखा होगा बहुत सही, जब आप ज़्यादा देर तक बैटरी यूज़ करते हो, अगर बैटरी इट विल लाइक थोड़ा फूल जाता है, कुछ डिस्टर्ब हो जाता है. तो एज पर द कंपनी says that your battery life is 5 years. If the company says your battery life is 5 years, तो इसका मतलब ये 5 साल तक उसको यूज़ करने के बाद चेंज करना ही है. We should not go beyond this. Why I'm saying? Because if you go beyond this, there may be a chance of burning inside the battery. So please take care when the company gives us some instructions about the battery charging. Now the system converts to an intelligent transport system. And this is a very important. What is an intelligent transport system? When we are understanding about the intelligent transport system, this is somewhere related to the traffic light controlling, autonomous vehicles, how our vehicles are connected together. One vehicle is going 10 meters away, then again next vehicle is coming. So how two vehicles can understand the distance between them. This is all about the electrical or the intelligent transport system. First transport system or first traffic light system has been developed in London in 1868. And traffic light were developed marking and beginning the modern ITS, that is 1912. ITS gained the momentum with a project like a comprehensive automobile traffic control system in Japan in 1960. These are the developments in the intelligent transportation systems. Then the navigation comes. Now we are using the GPS. So navigation comes in 1980s. Now we implemented the toll collection system, a smart traffic management system in 1990s. Although India used this later on, but it has been introduced in the world in 1990s. First ITS Congress, leading establishment of national ITS organizations worldwide, was held in Paris in 1994 after introducing such things. GPS and real-time traffic updates will come on 2000s. Absolutely, sir. So what is the role of the intelligence here? Because what is coming, that is an intelligent transport system. Now we have to understand what is the role of the intelligence. Intelligence comes with artificial intelligence, a word. Intelligence comes with IoT, Internet of Things. Intelligence comes with big data analytics. Intelligence comes with edge and cloud computing. Intelligence comes with autonomous and connected vehicles, which I'm talking about. Here we can see that there are so many artificial neural networks. Already madam has rightly said, because this is an area of her, because this is a she is working with the convolution and neural network, or the AIML, various AIML techniques, definitely helps to drive the vehicle independently. You can visit the China, you may visit the any other China, Japan, this or South Korea or North Korea, where autonomous vehicle systems are there. No driver are there. No driver. You have to call the cab. Cab will come at your place, pick up the cab, insert your code, sit, and you will reach your destinations automatically. There are no driver inside the car. Fully automated system with several use traffics. There are so many sensors are used. So many sensors are used inside the car. Second is IoT. IoT, because we all are using the IoT sensors, it means the IoT plays a very vital role inside it. And every data of the car or the autonomous system has to be put on the cloud. This is the main of the IoT here. Next, the big data analytics, edge cloud computing, and autonomous and connected vehicles are also plays a very vital role for make our transportation system intelligence. So here we can see that we have a different type of transportation systems. One is called the surface transportation systems. Surface transportation systems like on the road, on the water. On the road we use the train, vehicles, in the canals. Transportation system, intelligent transportation system, already I have told you, the thing which is basically connected to the AI/ML management systems, right? Now, air transportation system is also a very intelligent transportation system. आप कभी देखेंगे कि आप एक ऐप डाउनलोड करिएगा, जब आप देखेंगे कितनी सारी फ्लाइट्स हमारे ऊपर उड़ रहे हैं, हम तो कभी एक आध फ्लाइट को देख पाते हैं. There are several flights are flying. How they are managing? थोड़ा सा भी ऊपर नीचे हुआ तो गए. The transport system for the airways also a very intelligent transport system. Now other one is a hybrid intermodal and cooperative transportation system. You can see that for example you are ordering something to the Flipkart and that will be reach you by the 3 days. He will told you before you ordered. आप उसको ट्रैक कर सकते हैं, आपको पता चल जाता है 3 दिन में मेरा ऑर्डर आ जाएगा. किसी भी हालत में उनकी लाइबिलिटी होती है, वो 3 दिन या मैक्सिमम 24 आवर्स डिले करके आपका ऑर्डर पहुंचाते हैं, बिकॉज दे बिलीव दे ऑन देयर पर्टिकुलर ट्रांसपोर्टेशन सिस्टम्स. And how it is possible? This is an intermodal transportation systems. These are the ITS challenges. There's so many challenges. When the technology comes, definitely challenge comes. हर टेक्नोलॉजी के पीछे क्या होता है? एक चैलेंज. Yes or no, sir? The first challenge is infrastructure limitations. We do have, definitely we have to agree that we are facing the infrastructure limitations. Data and privacy and security systems. This is also the one of the biggest challenge in the ITS. Because when the vehicle comes to the infrastructure or V2I, then it gives the various challenges to us. Then another one is interoperability. Then public acceptance and awareness. This is also the challenge. Now we can also understand that some of them are using the EV. Although it is very useful to us, we know that if we use the EV, we will save a lot of money. We can save our environment. But we are not using. Why? Because now the fuel we have. When the fuel is vacant or empty, definitely we have to move on. These are the technologies for the ITS, wireless communication system. For the ITS, sensing technologies, video vehicle detections, Bluetooth detections. आपने देखा भी होगा बहुत सारी कार्स में बहुत सारे कैमरेज आ चुके हैं. आज ऐसी भी कार आ चुकी हैं अपनी इंडिया में, हम लोग चलाते ही हैं, बस आप स्पीड दे दीजिए और अपने आप वो चलती जाती है, अपने आप रुकेगा, अपने आप ब्रेक लगेगा, गाड़ी आएगा तो अपने आप स्टॉप हो जाएगा. यस और नो? So these all things are dependent on the technologies. How the technology plays a vital role in this particular things, then you have to understand. One important technique is vehicle platooning in ITS. This is very much important because when two vehicles both are not having a driver, how they understand that? So every vehicle is connected to another vehicle. This is called the V2V communications, vehicle to vehicle communications. Or for that purpose, because when we are driving or my car is running on that road and another car also running in a road, If the driver is not there, it means my car is also a driver. Yes or no? Yes. So my car has to know then other car how far it is and what action should I take. Move right or move left. Every information should be there. So these vehicle to vehicle communications are very important for this particular technologies. So this is called the vehicle platooning technology. How it is works? There are some application layers we studied. Computer science students we studied application layers, database layer, network transmission layers, and perceptive layers. These are the main layers which plays a very vital role in the intelligent transportation systems. Another one is a V2X, that is a cellular vehicle to everything. Now my vehicle is become a cellular because everything is there. My vehicle is automated driver. Cellular because it's receiving or sending. Now it's called a cellular. The cellular vehicle to everything. It's connected to mobility platform that allows vehicle to interact and with their surroundings such as other vehicles, cyclist, pedestrian, road infrastructures, and mobile networks. Everything will get updated through the vehicle. But unfortunately, when these such vehicles comes in the market, our electrical engineer comes into the role. Because my vehicle is charging through the electricity, my sensors are also working with electricity, the impact on the grid will be higher. So, if my vehicle is intelligent, then my grid should be intelligent or the smart. Otherwise, it could not cope up with the intelligent transportation system. Isn't it? Agreed or not? That is why a smart grid comes into the role. And these smart grids having a capability to handle all your vehicle, having the charging facility, to compensate the load accordingly, to maintain the load shedding, everything is there. Or main thing, give the on the data basis informations on the particular point with the accuracy. Right now we are basically using the traditional grids, having a several grids are traditionals, some of the smart grids. So what is the main difference? The traditional has a one-way flow and the smart grid has been having a two-way flow. Traditional gives or take, but the smart grid can give or received. Monitoring are real-time monitoring system enabled in the smart grid. Real-time monitoring system, what is happening out there. But it's not possible in this traditional grid. The EV integrations is support. Smart grid support, but traditionals does not support. Now efficiency is highly optimized in the smart grid. So impact of the EVs on the grid are very much higher. As I already told you, the EV charging is the biggest issue. You can say why we are not using the EV. This was my question. But sir, give the right. But hereby the answer I would say, sir. But the reason is we do not have a charging facility everywhere. If we having a charging facility within a 10 kilometers or the 13 kilometers, definitely everyone will buy. But right now we are having you don't have a charging facility within a 200 kilometers. If you coming from the Delhi, you will get the charging facility in the Agra. So this is also the main reason. If your vehicle running for the 200 kilometers, if the charging is not there, you will not buy the vehicle, sir. This is also charging. Why the charging is not there? Because still we are in the developing condition for the smart grid. If we converted all the resources through the renewable energies, then definitely we can do it. But right now the country is also facing the several challenges in the fossil fuels. We are right now, the latest research told the 55% energy also right now generated from the coal. That is why you heard the one news, if you remember, the last few days back, the Singrauli, there is some plant is there, the coal mines is there. The one 10,000 hectare jungle is cutting for getting the coal. 10,000 hectares jungle. So the future is the smart grid with electrical vehicles. This is the future. Because if you are having a capability on the grid, then your vehicle may be successes. If you are having a smart infrastructures, your vehicle may be success. And this is what the Norway country does. He started working to develop their infrastructure first, then introducing the car in the market. But right here, what we do, we introducing the market, or introduce a car in the market, but the infrastructure is not there. But the Modi has some vision. Definitely Prime Minister will do it later on in couple of days. Typical EVCS, this is an electrical vehicle charging system. Here we can see that we are having a different types of chargers, ultra fast chargers, and plug-in chargers, or independent charging system also developing. For example, if you want to charge your car in the very remote area where there is no electricity connections, so they are developing the solar-based electricity chargers. Now this is some study. I took it from the IIT Kanpur website. This study shows that we have the conventional load plus EV charging load, that is very much higher. It's approximately 125 or nearly 125 gigawatts. Here we can see the peak saving fully coordinated load is approx 134 gigawatt. So this is all about the EV infrastructures. But EV carbon footprint already I have discussed. This is a production cost. Here you can see that the Norway will generate almost its electricity from the renewable and hydropower. Break-even points would come just to 8,400 miles. It's approx 13,500 kilometers. In United States, where 25% of electricity comes from the coal-fired plant with a 54 kilowatt hour. It's approx 22,000 kilometers or 13,500 miles. Similarly, China, if the electricity is recharged by the EV comes entirely from the coal, which generates a majority from the power in the countries such as China, India and Poland. Mainly electricity comes from the coal. In these countries are China, India and Poland. That is why these countries are not focusing about the developing the infrastructures as well. Now the battery issues is here, sir. Comparison of the battery. Now we can see that if we check or the different type of battery like lead acid, NiCd, nickel cadmium, NiMH or lithium ion battery. Right now we have the lithium ion is the best solutions. There are several tests has been done for the thermal and state of charges. In the couple of study, they introduced the lithium ion battery are very much safer battery rather than the others. Because the lithium phosphate, when it comes to the market, lithium phosphate is also a good battery. It's nearby, if you have comparison with the lithium ion and lithium phosphate, the lithium ion is better. Then market demands the fuel cells based. And as for the fuel cell studies comes into the market, that is 1839, where you can see this particular fuel cell. Now you can also understand now everyone is running behind the hydrogen, and it's a fuel. And later on, because sir is also saying rightly that at that time the vehicle definitely will obsolete, but once the hydrogen will come up as a fuel, definitely our vehicle will be converted into the hydrogen versus battery. Battery will be there because we are having a 70% of the water on the earth. But that is very easy to extract the hydrogen from the water as well through this particular process, electrolysis process. This is a modern hydrogen infrastructures where solar cell, power unit, normal pressures, mechanical compressors, hydrogen tank are connected together and take the similarly hydrogen or extract the hydrogen from the fuel. Hydrogen infrastructure is basically developed through Japan first, that is a 25 hydrogen fueling system by 2020 at Tokyo. South Korea also done good. United Kingdom, California, and hydrogen mobility Europe. These countries are taking a very things very positively in this particular area. It's a fuel cell based history. You can see some buses are also running through the hydrogen. Here you can see this is first green bus is in the Italy. The photo, I just take this particular photo from the websites. Other one is Argue Switzerland bus. This is also based on. This bus is hydrogen based bus. And recently India also used this hydrogen based bus. Recently development hydrogen, in a hydrogen we invested a lot of money for taking the fuel or converting this particular fuel. On 16th of March, Nitin Gadkari already told about the green hydrogen is a future. Similarly, the train also running on the base of the hydrogen. This is a solution, smart solutions for this. National Green Hydrogen Mission in India is supported to this particular mission and invested a lot of money for extracting the hydrogen from the market. The conclusion, what is the conclusion is electrical vehicle represent the multi-system innovations. Smart grid and ITS are mutually reinforcements. Powertrain design, battery intelligence, smart grid infrastructures must involve together to create the seamless, efficient and sustainable mobility. Need coordinate planning, utility plus government plus EV industry. These are the main point of this particular presentations. So thank you so much everyone. यदि कोई डाउट कुछ हो तो पूछ सकते हैं आप. सर
kindly elaborate us the distinguish between lithium and hydrogen. What is the difference for e-garbage in both categories?
Sir, hydrogen is a fuel, sir. No. Hydrogen is a liquid. Just like a CNG. Like a fuel. It's a petrol like a fuel.
It is better than lithium battery?
No, sir, we cannot comparison with the battery. Why I am saying because it's a fuel. If you compare with the hydrogen and the petrol, then I can give the example. The hydrogen is a fuel and lithium is basically battery is made up from the lithium.
As far as concerned with e-garbage, so
the battery is the main issue. Yeah, garbage. Yes, absolutely. We are having a different process for the restoring our batteries. आप लोगों ने कितने लोगों ने बैटरी मार्केट में बेची है? प्लीज बताइए, बेची होंगी ना? पैसे मिले कि नहीं मिले? आपने सोचिए आपको मार्केट में 5,000 रुपये आपकी बैटरी खरीदते हो आप और उसको वो सामने वाला ना 5 साल यूज़ करते हो आप, तब भी वो 2000 में ले लेता है आपकी बैटरी। क्यों? सोचा कभी आपने ऐसा क्यों? यस, आपकी बैटरी पूरी डिस्पोज हो रही नहीं है, वो उसमें कुछ ना कुछ थोड़ी सी माइनर प्रॉब्लम होती है, उसको करके वो चेंज करते हैं, देन आपकी बैटरी फिर मार्केट में आ जाती है। ई गार्बेज आता है, ऐसा नहीं कि नहीं आता है, लेकिन उतना नहीं आता है। बैटरी ऐसा नहीं कि पूरी की बैटरी को छोड़ना है हमको, वो कुछ होती है बैटरीज, इट्स नॉट इट इंड्यूस गार्बेज। आई एम नॉट सेइंग कि ऐसा नहीं होता है। जैसे आप बोलते हैं सोलर पैनल, सोलर पैनल में भी इतने एल्यूमिनियम्स होते हैं, जो आपने देखा कॉर्नर में लगा होता है, वो भी गार्बेज क्रिएट करता है। यस और नो? तो उसकी रिसाइकलिंग होती है। यस, तो कुछ चीज़ें रिसाइक्लेबल हो जाती हैं, जैसे आपकी प्लेट्स देखी हैं, प्लेट्स रिसाइक्लेबल हो जाती हैं। कार्बन आपके पास ऑलरेडी है, वो कार्बन को हम डिस्पोज नहीं कर सकते, तो इसी को हम रीयूज़ करते हैं।
तो हमें शायद आगे कभी प्रॉब्लम नहीं आएगी, जो अभी हम रिन्यूएबल सोर्स के बारे में बात कर रहे हैं, क्योंकि हाइड्रोजन यूनिवर्स का मेन कंपोनेंट्स है, और ना वो कभी ख़त्म होगा, और ना हमें फ्यूल सेल में रिचार्ज और ये तमाम तरह की जो प्रॉब्लम्स क्रिएट हो रही हैं, जैसे कोल की तरह और लेड स्टोरेज सेल की तरह, लिथियम भी अगर हम देखेंगे तो अफ़गानिस्तान पे डिपेंड रहेंगे, अफ़गानिस्तान के एरिया में वहाँ से लाना पड़ेगा। और जैसे पेट्रोल के लिए हम लोग ईरान के ऊपर डिपेंड है, कुवैत के ऊपर डिपेंड है, तो डिपेंडेंसी ख़त्म हो जाएगी और हम लोग आत्मनिर्भरता की तरफ कहीं ना कहीं जाएंगे।
सर, आपका शुभ नाम? सर, डॉक्टर नवीन चौहान जी के लिए बहुत जोरदार तालियां। इन्होंने मेरा कंक्लूजन बता दिया इसका। सर, थैंक यू सो मच सर। सर,
one thing is there, hydrogen has high calorific value. We cannot control. That's why actually we know hydrogen from very beginning, from ancient time. But as it has high calorific value, that's why we cannot control. That's why we are not.
हाइड्रोजन सर,
मेरे को नहीं
as far as the calorific value is concerned of the hydrogen, it affects several factors.
हाइड्रोजन एक्चुअल में क्या है, यूनिवर्स में जब हम बात करते हैं तो हाइड्रोजन 3 फॉर्म में हमें मिलता है, प्रोटियम, ड्यूटेरियम और ट्राइटियम। और जब हम जैसे सन की एनर्जी की अगर हम बात करते हैं तो सन क्रोड में सबसे ज़्यादा ड्यूटेरियम है। ड्यूटेरियम न्यूक्लियर फ्यूज़न के थ्रू हीलियम में कन्वर्ट होकर मेगा इलेक्ट्रॉन वोल्ट में एनर्जी रिलीज़ करता है। तो आने वाले समय में जब हम लेंगे तो डायरेक्ट तो नहीं लेंगे, हम काम क्या करेंगे, ड्यूटेरियम को किस में चेंज करेंगे, हीलियम में, और हीलियम से मेगा इलेक्ट्रॉन वोल्ट में एनर्जी हमें मिलेगी, और ये इस तरह की कोई प्रॉब्लम नहीं आएगी।
Sir, for that na, for nuclear fusion, 10⁹ degrees centigrade is required.
Yes.
It is not possible on the Earth.
Thank you so much sir. Thank you so much.